Hey everybody. Today we're going to wrap up our unit on square roots and inverse functions. We'll review and then you'll have your last test. So let's go ahead and jump into things. I'm going to be using Desmos a lot today. So if you want to open up a Desmos tab and follow along as I go over these problems, I think that would be a wonderful idea. So here we go. In order to solve equations that involve two different types of functions, graph each side of the equation separately. Use some sort of calculator or Desmos to find the intersection of the graphs. The x value is the solution. And sometimes there may be more than one solution. So looking at this right here, this is telling us that when you're solving an equation, not just these square root equations, not just the inverse equations, but a linear, a quadratic, any kind of equation, if you're trying to solve it, another way of solving it that you can do besides the algebraic way that we've gone through and done it, you can graph the left-hand side of your equation, graph the right-hand side of your equation, and your solution is where they intersect. So that would be a good way for you to solve your equation if you need some additional help. So for the first one here, we're going to solve this equation. So yes, I can solve it by squaring both sides, moving everything over, and factor it. But today we're going to try to solve it by using this intersection feature that we're learning about. So I'm going to pull up a Desmos, and I've already typed this one in, but again, follow along with Desmos. And I've already put in the square root of x plus 4, and I've already typed in x minus 2. Your solution is where they intersect. So I can see they intersect right over here. Desmos will highlight that point for us, and that point is 5, 3. Your solution is the x value of where it intersects. So my answer for A, x equals 5. So we graphed each side of the equation in Desmos or some sort of graphing calculator. I graphed the left-hand side, I graphed the right-hand side, see where it intersects, and I got 5. Okay, so let me get rid of these two and we can move on to the next one. So now I'm going to be doing B. So on the left-hand side of your screen, you should see B on my note sheets here. So this is the one that we're solving now. So I've already graphed in 1 divided by x, and I've already typed in and graphed the square root of 2x minus 1. So let me highlight that. Highlight. Your solution is where it intersects. Again, I can see this intersection point right here between the purple and the green. If you click on Desmos, it'll highlight that point for you. Your solution is the x value. So in this case, they're both 1, so you would have got it right. But I want to make sure you know your solution is the x value. So x equals 1. Okay, so that's that one. Next, let's take a look at C. X squared minus 5 is equal to 2x plus 1. So let me highlight this and highlight this. So x squared minus 5, the black is a parabola, and the one in the red is a linear equation. Now keep in mind your solution is where it intersects, and you can have more than one answer. So looking at this linear function in a quadratic, I see two different solutions. I see a solution up here that I'll highlight, and I also see a solution down here that I will highlight. Your solution is the x value of these intersection points. So one of them is this. So again, I got that right from Desmos, just copying it down. And then my other solution that I found, the x value is this. And ta-da, that's all there is to it. So you can find your solution to these different types of functions by typing them into Desmos or any sort of graphing calculator and see where they intersect. So that's the example 1. Now we're just going to end with some application problems. It's important to be able to read and decipher and answer whatever the question is trying to tell us. So let's take a look at some application problems. The formula for the volume of a sphere is as follows. A spherical water tank holds 15,000 feet cubed of water. Find the diameter of the tank. So we want to find the diameter in this equation right here. And they give us that it holds 15,000. So 15,000 is going to go in place of my V. So 15,000 is going to go in place of V. So that's going to give me 15,000 is equal to 4/3 pi r cubed. So I do know that I'm looking for the diameter, but in this formula, it gives us radius. Our relationship between radius and diameter is that you just multiply it by 2. So if I can solve this equation for r, I'll be good to go because then I could just multiply that by 2. So again, make sure you're typing your numbers into Desmos. It's going to get kind of messy. I got this improper fraction here. We'll probably run across some decimals and things like that. So feel free to put these numbers in Desmos as you're working it out. So this is 4/3 pi times r to the third. So since I am multiplying by these two things here, I can undo multiplication by dividing. So in one fluid step, I can divide both sides by 4/3 pi. And I can divide this side by 4/3 pi. So in Desmos, you would type in 15,000 divided by 4/3 pi. You can type that all in one fluid step, and it will give you this number here. So again, you can type that all in Desmos. Make sure 15,000 is all in your numerator. Make sure this is in fraction form and you're multiplying times pi. You can type that all in Desmos in one fluid step, and it'll give you this 3,000 number. Now, the opposite of cubing something is to raise it. We're going to raise it to the 1/3 power. So I need to undo this by finding the cube root of this here. So let me show you how to do that in Desmos because that part might be new. So over here in Desmos, so we're going to undo, and let me make sure you can see the problem. Okay, there we go. So this is equal to r to the third. So we need to find the cube root of this number here. So if you go down to functions, and it's underneath miscellaneous, and you see this button here. Let me go through that. That was kind of fast. So miscellaneous, and this button that has the n for the index and the square root, the radical symbol there, that's the button that I hit. So I'm going to put 3 on the outside, and on the inside, I'm going to type in this number that we got. So for my radius, I got 15.299. So 15, I'm going to keep some of these numbers. I'm going to keep some of them. So that is what r equals. So let's go through that again. R to the third equals this number here. That means the opposite of cubing something is to find the cube root of it. So I went down to functions in Desmos. I went to MISC, that's miscellaneous, and I hit this button here that has the N on the outside with the radical symbol. You type in the number that you have, and this is now my radius. Now, if I go back and read the problem, it does not want to know what the radius is. This problem says find the diameter. So it says find the diameter. So all you have to do is multiply this number by 2. So again, it's already in Desmos. So I can take that number and I can multiply it by 2. So my diameter is, and I'm going to round to the nearest tenth. So my diameter is 30.6. And this is my diameter. Okay, so that is the answer to that one. So Desmos definitely helped us out with some of those numbers and calculations. It said find the diameter. The diameter is 30.6, 30 and 6/10. All right, number 2. The weight P in pounds that a beam can safely carry is inversely proportional to the distance D in feet between the supports of the beam. For a certain wooden beam, P equals 9,200 divided by D. Find the distance between supports that is needed to carry 500 pounds. This is an inverse variation problem. I know that because of the way that the problem is set up. We normally do Y equals K divided by X. They're just using different letters, but K is my constant of variation. So all I need to do is plug in 500 in for P, and I know that because it's pounds, and up here it tells me weight in pounds. So P is where the 500 goes. We're trying to get D by itself, so you multiply both sides by D. So that gives me 500D is equal to 9,200 because these D's cancel out. So the opposite of dividing by D, I multiply both sides by D. And we're trying to get D by itself, so just divide by 500. And we will type all this in Desmos or some sort of calculator. And D equals, it's going to give me 92 over 5. And as a decimal, it gives me 18.4. So that one wasn't too bad at all. So not bad at all. Number 3. A basketball player has made 21 of her last 30 free throws, an average of 70%. To model the player's rate of success if she makes X more consecutive free throws, use the following function. Use the graph to find the number of consecutive free throws the player needs to raise her success rate to 75%. I am going to graph this one. So we are not going to work it out. I'm going to graph it. So I'm going to pull up my Desmos here. And I've already typed it in. So you're going to type in y equals 21 plus x divided by 30 plus x. Okay. So let me highlight that. So we are looking for, the question says, use the graph to find the number of consecutive free throws the player needs to raise her success rate to 75%. So I'm just going to use the trace feature, and I'm going to be looking for 75%. So, and that's going to be my y coordinate because the x is her attempts, and then the y is going to be her percentage. Okay, so right now I'm at 70% as I travel here. So, okay, there we go. So I'm traveling. I'm at 73%. I'm looking at the y coordinate, 74%, 75 should be coming up, and there it is right there. So 6, and I moved it just a little bit. Okay, there we go. 6 is the x, and 0.75 is what we're looking for. So the question says, use the graph to find the number of consecutive free throws the player needs to raise her success rate to 75%. So the answer to this question is 6. So I simply just used the trace feature in my calculator, and I was looking for 0.75. You take your x coordinate. So the answer to this question is 6. X equals 6. And we use the graph for that. Number 4, the relationship between distance, rate, and time can be calculated by the following equation, where R is the rate, D represents the distance traveled, and T represents the time. If the speed of the wave from a tsunami is 150 meters per second, and the distance from the disturbance in the ocean to the shore is 35 kilometers, how long will it take the wave to ride the shore? So they give us a formula there. We are using this formula, R equals D divided by T squared. We just need to make sure we substitute the correct numbers in the correct spot. So 150 is going to be my R. 35 is going to be my D. And we're looking for time. So how do I know that? Because down here, 35 kilometers, that's a distance. And up here in the problem, it says D represents the distance traveled. So it traveled 35 kilometers. I know 150 is my rate because it's the rate in terms of speed up here in the problem. And it tells me 150 meters per second. So that is my speed. Now I just need to solve this equation for T squared. So if I solve for T squared, I'm going to do 2 steps in one. So follow me for a moment here. The opposite of dividing by T squared is to multiply both sides by T squared. And then you'd have 150 times T squared, and you need to divide by 150. So if I do that, that's going to give me T squared equals 35 divided by 150. So T squared equals 35 divided by 150. The opposite of squaring something is to take the square root. And in our friend Desmos, I can type all this in. So let me get rid of that. I can type all this into Desmos. Let me slide this over a little bit so we can see the problem. There we go. So I will use my square root button that's down at the bottom. And I'm probably going to have a hard time getting to it because I got all this stuff open. So let's move this out of the way. Okay. All right, so I got all this stuff open at the bottom, but in Desmos, you would type in the square root of 35 over 150. A shortcut that I can do, I can just raise this to the 1/2 power. And I got 0.48. So T is equal to 0.48, and this is seconds. So I had a little bit of issue because I had all my stuff open since I'm making my video, and I can't get down to the bottom where my square root is. But in Desmos, you would just type in the square root of 35 over 150, and it should give you this 0.480 number here. So just type that in. It's no problem whatsoever. All right, so this has just been a quick little recap of all things we've been doing the past few days. We got square root functions, inverse functions, and we've gone and did some word problems. So now you should be all prepared. There is a review that we're going to be doing, and you got a test coming up.